Before I start teaching you exponents, uh, one thing I will like to stress is that please treat mathematics as a language instead of a subject. And every mathematical expression like into and addition and these exponents, all these expressions are in fact are language. And before doing any sum, you should first translate meaning of that expression into a language. And if you get into that habit, you will find mathematics to be very easy. It's this disconnect that we don't realize that mathematics is a language that creates lots of problems. And most of the weakness of students in mathematics is related to this fact only because they don't understand that it's a language. And when you are not able to catch the language part, you find the subject very difficult. To explain what I have in mind, how to treat mathematics as language. So before I start experiments, I will try to explain this aspect with the help of the multiplication operation. Before we start learning exponents, we should first try to understand what is language part in uh, mathematics, and for that I'm trying to explain that language part of mathematics uh, with the help of multiplication operation. For most of us, 4 into 5 is an instantaneous 20. 5 into 4 is an instantaneous 20. And we hardly realize any difference between the two since the answer is same. But if you treat mathematics as a language, then you will realize that both are very different operations. And if you get that part of it, then you will know that uh, mathematics is a language, and it is very important to get that part of this language uh, to be able to understand the subject very well. Now, 4 into 5, basically this expression multiplication, meaning of this expression multiplication is repeated addition. So, when we say 4 into 5, what we are saying, add 4 5 times. Add 4 to 4 5 times. That is 4 plus 4 plus 4 plus 4 plus 5 times. 5. So 4 plus 4 8, 8 plus 4 12, 12 plus 4 16 plus 4 20. So basically when we say 4 into 5, we mean 5 fours. 1, 2, 3, 4, 5 fours to be added together. Similarly, when we say 5 into 4, what we mean by this is add 4 5s together. That is 5 plus 5 plus 5 plus 5. And it again comes to 20. 5 plus 5 10 plus 5 15 plus 5. But if we get language part of maths, multiplication means 4 into 5. This is yelling at us, it is conveying us a message that you have to add 4 to 4 5 times. Or in other words, we have to add 5 fours altogether. We have to add 5. When we say 5 into 4, it is telling us that you have to add 4 5s. Take 4 5s and add them. So it is very important that when we are saying 4 into 5, we should get this one. We should not forget this one. When we are saying 5 into 4, we should not forget this one. Why we need these mathematical expressions like multiplication? Suppose we have to add 5 into 5 20 times. How we will write it? If we don't have this expression, we write it something like this. See how tedious it looks. It takes so much of time, it occupies so much of space, and it is not obvious what we are doing. We have to count fives to know that we are adding five fives 20 times. 1, 2, 3, 4, 5, 10, 15, 20. So to save this time, space, and to also get the information at a glance that we are adding 25, we need mathematical expressions. So, sorry, this it can be simply written as 5 into, and it conveys the same message. It conveys the same message that add 5 to 5 20 times, or add 25s one after. So this is why we need these mathematical expressions. But if we are using 5 into 20, we should not forget this part, that what we are doing. And if you keep this language part of mathematical symbols expressions in your mind, you'll find that exponents are very easy to deal with. And I have selected this topic to teach you people because I find that most of these students are very confused about exponents. So I want to clear all your doubts in one video. I will try to cover every type of question, situation of related to exponents in this one video. So that if you watch this video and wherever you happen to be dealing with exponents, you will be having all the tools necessary to do those kinds of calculations. So watch this video very carefully. I am explaining everything in a very detailed manner. You won't find that kind of detailed treatment anywhere else. So let's first get the language part. Suppose, see, multiplication was for repeated addition. That is 1, 2, 3, 3, 6 fives. So we should write 5 into 6. So what will, we can have a similar situation with multiplication as well. We might have a situation where we have to multiply 6 fives repeatedly. Obviously, it will do a lot of good to us if we are able to shorten this expression with the help of some expression that will tell us that we are multiplying 5 with 2 5 6 times. We are multiplying 5 6 fives together. And for that we need exponential, exponential, and we convey this simple information with the help of 5 raised to 6. So now it is very simple. 5 raised to 6 means 5, 6 fives, 6 fives, 1, 2, 3, 4, 5, 6 fives to be multiplied with themselves. So what will be 5 raised to 7? It will be 7 fives. 7 fives multiplied together. Okay. So if I have 2 raised to power 3, it is 3 twos multiplied together. 3 twos and obviously it is 8. 2 into 2 4. So 2 5 is 5 twos multiplied together. 1 2 3 4 5 twos multiplied together. So 2 to the 4 to the 8 to the 16 to the, we can do it vice versa also. Vice versa is represent in exponential form. Okay. So we have to represent this expression into exponential form. Simple. 1, 2, 3, 4, 5, 6, 7, 8. 8 sevens multiplied with themselves. 8 sevens multiplied with themselves. So in exponential form, like 8 sevens. 8 sevens. 1, 2, 3, 4, 5, 6, 7, 8 sevens multiplied together. Let's do one more example. Sorry. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 threes to be multiplied together. So we write it in the form of 3 raised to power. This means 9 threes. 9 threes means 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 threes to be multiplied together. Clear? So we try to express it in some general form. So we have x into x into x. It is 3x's multiplied together. So x raised to power x into x into x into x into x. How many x's? 1, 2, 3, 4, 5. 5 x's multiplied together. So we write it as x raised to power 5. So if we have n x's multiplied, these are n x's. 1, 2, 3, 7, 100, 200, 1000, lakh, n. And so if we are multiplying n axis, we will write it as, we are multiplying n axis, we will write it as x. So in case x raised to power n is equal to 5, then it becomes n x raised to power 5 is equal to x into x into x x. If n is equal to, let us say, 3, then it will be x raised to power 3, that is x into x into. Okay, so how this general form is to be used? Now we are querying. Okay. For that, to be able to calculate, we should know the value of n. And obviously, it will be different in different sums. If it is 3, so it will be x raised to power 3, so x into x into x. And let us say, if it is n is equal to 6, then it will be x raised to power 6, that is x into x into x we can have a situation like this. 1 by, let us say, 2 into 2. Now, instead of in numerator, we might have repeated multiplication of a number in denominator. Okay. We hope you know what is numerator, what is denominator. Just say it is an expression 3 by 5. Here, this is numerator and this is denominator. So, in a fraction, the number on the top is numerator and the number at the bottom after this division sign is denominator. So far we were dealing with repeated multiplication in numerator only. That was very easy, 2 raised to power 4. But if we have repeated multiplication in denominator, no problem. It will be 1 raised to power 2 raised to power 4. Same. Isn't it? So if we have repeated multiplication in denominator, no problem. Same thing will happen. 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 raised. 9 threes. 9 threes multiplied together. Multiplied with themselves. Any problems of? But then, what we do actually, we go a step further and we write it as 2 raised to power minus. You will say, why sir? The answer is it is a by convention. We have chosen to write 1 raised to power, 1 divided by 2 raised to power 4 as 2 raised to power minus. That is, if in denominator we are multiplying 4 2's with themselves, then we can write it as 2 minus 4. 2 minus 4 means in denominator. In denominator we are multiplying 4 2's with them. By that token, if we have 3 raised to power minus 6, this means in denominator we are multiplying 6 3's. 3 into 3 into 3, 3 into 3 with them. So no problem so far. So we, let's say once again one more step. Let us say we have 4 raised to power minus 5. We can write it as 1 by 4 raised to power 5 or 1 by 4 5 multiplied together. Any problem so far? I hope you won't be having any problem. But we have to keep in mind that it is a language. This language has a specific meaning. 4 raised to power 5 will always mean 5 fourths. You have to take 5 fourths and multiply them. Now, when 4 raised to power minus 5, that is in denominator, you have to take 5 fourths and multiply. So, what is difference between 2 raised to power 4 and 2 raised to minus 4? Simply 2 raised to power 4 in numerator. In numerator, you have to multiply 4 fourths with that. But if it is 2 raised to power minus 4, that means in denominator, you have to multiply 4 fourths, 4 twos. So it will be 8 and it will be 2, 4, 8, 16 and it will be 1 by 6. Similarly, 3 raised to power, let us say 3, it is in numerator, 3 3's to be multiplied together. So it will be 3 9 27. If it is 3 raised to minus 3, it will be in denominator. 3 3's multiplied together. So it will be 1 by 20. So far so good. Now one last situation. We can have negative power in denominator as well. We can have negative power in denominator as well. So now what to do? This means 1 minus 4. Okay. And we know 2 raised to power minus 4 is 1 by 2 raised to power 4. Clear? So it is equal to 1 divided by 1 by 2 raised to power 4. Now if we have to divide a fraction with another fraction, what we do? We change this division sign to multiplication and write reciprocal of this expression. The next expression that follows this division sign, not this expression. The fraction that follows division sign, we change this to multiplication and write reciprocal of that expression. Like if we have to divide 3 by 2, we use the same 4 by 5. How we will do it? We will do 3 by 2 multiply by reciprocal. Reciprocal by means numerator becomes denominator and denominator becomes. So this is reciprocal. This is reciprocal of 4 by 5 is 5 by 4. Similarly, reciprocal of 7 by 2 is reciprocal of 7 by 2 is 2 by 7. That is denominator becomes numerator, numerator becomes denominator. But mind this, reciprocals are not equal. Reciprocals are never equal. Reciprocal of a number is never equal to that number. That is 4 is never equal to 1 by 4. But they are reciprocal. Okay. Keep in mind. So reciprocal of a number is never equal to. So 3 by 2, okay, multiply by reciprocal of 4 by 5, that is 5 by. Same rule we will use here. So it will be 1 by 1 multiplied by 2 raised to power 4 by 1. Okay. So if we solve it further, we will get 2 raised to power. So we can write here it is equal to 2 raised to power. So by that token, if it is x raised to power minus n, it will be x raised to power n. Remember this. And if it is x raised to minus n, it will be 1 by x raised to, like these two expressions. Remember them, we will use them. So far so good, no problem. Now we will examine what further we can do with these notations or exponential notations. The first case in mind is, let us say 2 raised to power 3 and we have to multiply it with 2 raised to power 4. Now what to do? How to solve it? Okay, let us first see 2 raised to power 3 is 2 into 2 into 2 and this will be 2 raised to power 4 is 2 into 2 into 2. So in actuality it is 1, 2, 3, 4, 5, 6, 7. 2 raised to power 7. And we notice that it is actually 2 raised to power 3 plus So we can write it here. Let us try to solve one more example. Just say 3 raised to power 2 into 3 raised to power 3. So obviously it will be 3 into 3 and this multiplication, and this will be 3 into 3 into 3. And by convention, if we have to multiply 5 threes together, we can write it as 3 raised to power 5. And again we see is 3 raised to power 2. That is, in case 3 raised to power 2 is multiplied with 3 raised to power 3, all we have to do is add here powers. In multiplication, powers have to be added. In multiplication, powers have to be. So let us try to generalize it. If we have x square into x cube, it will be x into x into x into x into x. So by convention, 1, 2, 3, 4, 5. If 5 x's are to be multiplied, it should be x raised to power 5, which again we can write as x2 plus 3. So again it gives us same rule, but in case two expressions are multiplied with different powers, then we can add the powers. So it is x and x raised to power n. So it will be x raised to power n. So this is our fourth part. Last term we have done 3, so this is 4. Okay. Now let's examine what will happen if we have x raised to. Now let us examine what will happen if we have 3 raised to power 5 divided by 3 raised to power 2. Obviously, we can write it 3 raised to power 5 divided by 3 raised to power 2. And by notation, we know that 3 raised to power 5 is actually 5 threes. 1, 2, 3, 4, 5 threes multiplied together. 3 raised to power 2 means 2 threes. 2 threes multiplied. Now let us try to solve it. 3 1 the 3, 3 1 the 3. Okay. So this we can write as 3 raised to power. This we can write as 3 raised to power 3. So what we are noticing here, 3 raised to power 5 divided by 3 raised to power 2 is actually 3 raised to power 3, that is 3 raised to power 5 minus. So in case of division, powers will be subtracted. In case of division, powers will be subtracted. Okay. 3 raised to 2 raised to power 5, 2 raised to power 4. It will be 2 raised to power 4 is, sorry, 5 is 5 2s multiplied together. 2 raised to power 4 is 4 2s multiplied together. 2 1 that 2, 2 1 that 2, 2 1 that 2, 2 1 that 2. What we are left with is 2, and this we can write as 2 power 1. Okay. Now again that means in this case also, powers have got subtracted. So let us try to generalize it. If we have x raised to power 5 divided by x raised to power 2, we write it as x raised to power 2, 5 divided by x raised to power 2. X raised to power 5 means 5 x's multiplied together. X raised to power 2, 2 x's multiplied together. three x's are multiplied together, we can write it as x raised to power 3. So what does that mean? This means x raised to power 5 divided by x raised to power 2 is x raised to power 5 minus 2, that is x raised to power. So if 5 is equal to n and 2 is equal to n, I have x raised to power n divided by x raised to power n equal to x raised to power n minus. So we can have a situation that let us say x raised to power 3 divided by x raised to power 5. In that case, what will happen? It will be x raised to power 3 minus 5. And in that case, it will be x raised to power minus 2. So answer will be x raised to power. This is possible. Another possibility is x raised to power 3 divided by x raised to power minus 5. So in division, powers have to be subtracted. So be very careful. So this powers have to be subtracted, and now we will this way. So it is x 3 plus 5 x 8. Obviously, why so? Because we know 1 by x raised to minus 5 is x raised to power 5. We know this. So x raised to power 3 divided by x raised to power minus 5 is actually x raised to power 3 multiplied by x raised to power 5, hence 3 plus 5. So nothing wrong here. Often we come across such expressions. What will happen if 2 is raised to power? Now, if it is single 2, so it is 2 raised to power 1. That means 1 2 multiplied by itself. That is 2. So 2 raised to power 1 will be 2. 3 raised to power 1 will be 3. That means any number raised to power 1 will be number. So x raised to power 1 will be x. So if we have any number, let us say 5, we can write it as 5 raised to power 1. Why this becomes useful? Suppose we have to do 5 raised to power 2 into 5. So we should know it is 5 raised to power 2 into 5 raised to power 1. So now we will be able to do 5 raised to power 1. So we have to know that it is 5 raised to power 1 so that we can do this out. Okay. Now we come across a situation where it is power 0. So now how to resolve this? If a number is raised to power 0, how to resolve it? 2 raised to power 0, 3 raised to power 0. Not very difficult. We know 2 raised to power 0. I can write it as 2 raised to power, let us say 7 minus 7. Isn't it? So it will be 2 raised to power 7 into 2 raised to power minus 7. Right now, 2 raised to power 7 and 2 raised to power minus 7 is 1 by 2 raised to power 7. Isn't it? So it will become 2 raised to power 7 divided by 2 raised to power 7. It will be 2 into 2 into 2 into 2 into 2 into 2 into 2. This will again be 2 into 2 into 2 into 2 into 2 into 2 into 2. 1, 1, 1, 2 1 number, 2 1 number, 2 1 number, 2 1 number. 1 into 1 into 1 into 1 into 1. So 2 raised to power 0 is. Let us try to do it for x raised to power 0. We can do x raised to power, this is again 3 minus 3. That will be again x raised to power 3 into x raised to power minus 3. That will be again x raised to power 3 into 1 by x raised to power 3. That will be again x3 into x3 by x3. That will be again x into x into x divided by x into x into x, x1 by x, x1 by x, x1 by x. So 1 into 1 into 1 into 1. So again x raised to power 0 is also equal to. So any number raised to power 0 is equal to 1. So if I have 100 raised to power 0, it will be 1. Let us say 99999 raised to power 0, it will be 1. Another interesting thing is if we have 1, we can write it as 3 raised to power 0, we can write it as 100 raised to power 0, we can write it as any number raised to power. Okay. Now sometimes we come across situation like this: 2 raised to power 3 raised to power 4. So how to solve it? Let us first solve it. It is 2 raised to power 2 raised to power 2, 3 times raised to power 2. So it is 2 or 8. 2 to the power 2 or 8. 8 raised to power 2. And it is 8 into 8 into 8 into 8. Now I again convert it to 2. So it will be 2 into 2 into 2. Again this will be 2 into 2 into 2. Again this will be 2 into 2 into 2. And this will be 2 into 2 into 2. So just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it comes to 2 raised to power 12. So 2 raised to power 3 whole bracket raised to power 4 comes to 2 raised to power 12. Let us do one more example. 3 raised to power 2, let's say raised to power 4. Okay, so it will be 3 into 3, 4. 9 raised to power 4. 9 into 9 into 9. Again, we repeat them to 3. It will be 3, 3, this 9. Then again 3, 3, this 9. Then again 3, 3, this 9. Then again 3, 3, this. So now we have 1, 2, 3, 4, 5, 6, 7, 8. That is 3 raised to power. So but if I 3 raised to power 2 raised to power 4 is 3 raised to power 8. So we notice that it is here 2 raised to power 3 into 4. Same token we notice here 3 raised to power 2 into 2. So that means if we have x raised to power, let us say n raised to power n, it will be simply x raised to power n into. Let us put it more neatly here. So it is x raised to power n raised to power n, it will be x raised to power n. Okay. Let us put it as some last situation. Suppose we have 2 raised to power 4 into 3 raised to power 4. Okay, this we can write 2 raised to power 2 raised to power 2 raised to power 2. This we can write suppose I pair it with this, I pair it with this, I pair it with this, I pair it with this. It will be 2 raised to 2 3 the 6 into 2 3 the 6 into 2 3 the 6 into 2 3 the 6. And this I can write as 6 raised to power 4. So this is actually 6 raised to power 4. This again I can write as 2 into 3 raised to power 4. So I can again write as 2 into 3 raised to power 4. What does this tell me? This tells me if I have x raised to power a into y raised to power a, I can write x into y raised to power a. Or x raised to power m into y raised to power m, I can write it as x into y raised to power. This concludes our video 2. Now before introducing you to the next concept in exponents, I want to do some background work. Background work is very interesting. I hope you will enjoy that. Suppose if I have to go to, let us say, from city A to city B, then I should also be able to return back to city. Onward journey, then return journey. So this concept is applicable to every mathematical operation. What happens? We have problem, and by applying mathematical expression, we get solution. Now, from solution, we should be able to return back to problem. So this is onward journey, and this is return. So for every mathematical operation, like addition, subtraction, addition, multiplication, division, there is a return operation also. We will see what I mean by that. So, problem solution. Let us examine this for the side plus. So I have 5 plus 4 equal to 9. Now if I have to go to back, I can do it in two ways. 9 minus 4, it will be 5. Or 9 minus 5, it will be. So, for plus, okay, onward, we have negative return function. Similarly, if I have 5 into 4 equal to 20, so I have to do this way. 20 divided by 4, I will come to 5. Or 20 divided by 5, I will come to 4. So for multiplication, division is return function. Similarly for division, multiplication is return function. I hope you got this concept clear. Now we come to exponents. Let us say I have done 2 raised to power 4. So it is 2 into 2 into 2 into 2, 2 to the 4 to the 8 to the 6. So this is problem. This is solution. So for problem I have gone to solution. Now if I want to return back to the solution, problem, from solution to problem, I will need another expression. In exponents, I will need another expression that will guide me to this for that I have an expression that I will put into 16 4. What does this tell me? This tells me that there is a number that if raised to 4 or if multiplied 4 times, then 16 will come. So answer for this is this number. Answer for this is this number. That is again what it is saying 16 4th. It is telling me that there is a number that if multiplied by itself 4 times, it will result in 16. Tell me that number. That number is got this? So if I have a 3, it is asking me to find a number that if multiplied by itself 3 times will result in 8. And that number is my answer. We convert it into language 8 cube. We call it cube. It is, let us say, 16. This will be called square root. If it is say 16 4, so this will call 16 4th. And meaning of this is any number raised to, nth root is asking us to find a number cube that if multiplied by itself and number of times will give x. Hence, answer will be cube, that number. So 8 cube root, okay. It is asking me to find a number x such that if it is multiplied by itself 3 times, 8 will come. So that number x is the answer. Number x is the answer. So we know 3, 8. What I can do? I can factorize it. 2, 4, 2 to the 4. So it 8 equal to 2 into 2 into 2. So it is 2 into 2 into 2. But exactly it is asking me to find a number that if multiplies 3 times with itself should be 8. A number if multiplied by itself 3 times it should be 8. So answer is 2. Here it is asking me to find a number, okay, a number if multiplied by itself twice should result in 6. Twice we get from here. Now again we make it factors. 2, 8, 2, 4, 2. So 16 is equal to 2 into 2 into 2 into. Now square root 16 I can write as 2. Instead of 16 I can write 2 into 2 into 2. So now we have found a number that if multiplied by itself 4 times it will be 16. But it is asking me to find a number that if multiplied by itself 2 times should be 60. But we have found a number multiplied by itself is giving 4 times is giving us 60. But it is asking me to find a number that if multiplied by itself 2 times will be 60. No problem. For so now I have a number multiplied by itself 2 times that gives me 60. So my answer is 4. My answer is 4. And here it is asking me to find a number that if multiplied by itself 4 times will be 60. So it will be 2 into 2 into 2 into 2, 4. So 60 square root is 4, where 60 fourth root is. Hope this is clear. Now 16 fourth root, we have another convention to represent it. We represent it as 16 raised to power 1 by 4. Both means 70. 16 raised to power 1 by 4 is asking us to find a number that if multiplied by itself gives us 4 by itself 4 times gives us 60. 16 raised to power 1 by 2 means find a number if it is multiplied by itself 2 times it will give us 60. That we know, that is 4 into 4. So answer is 4. This is asking us to find a number that if multiplied by itself 4 times will give us 60. So this we know, 2 into 2 into 2 into 2, 2, 4, 8, 16. My answer is. Hope you got this. How to solve such questions? How to solve such questions? The test we are given 216 raised to power cube. 216 cube. Obviously, we can write it as 216 raised to power 1 by 3. But we have to find a number x such that if it is multiplied by itself 3 times, we have 216. So answer will be x. Again, method is same. Keep on factorizing it with the smallest number. 2 1 the 2, 0, 2 8 the 16, 2 5 the 10, 4, 2 2 2 the 4. Now it will go with 2, 3 3, 9 the 27, 3. So 216 is equal to 2 into 2 into 2 into 3 into 3 into 3. So I can write it as 216 equal to 2 into 2 into 2 into 3 into 3 into 3. Now we have how many numbers? So many numbers. We want a number that if multiplied by itself 3 times will be 260. No problem. 2 3 the 6, 2 3 the 6, 2 3 the. Now we have found a number that if it is multiplied by itself 3 times, we will get 260. So answer is 6. So answer for third root of 216 or cube root of 216, we can write it as also 216 by 1 by 3. I hope it is clear. x nth root, it is asking me to find the number y, which if raised to power n will be x. My answer will be y. If it is x, asking me to find the nth root of x, actually it is asking me to find a number which if raised to power n, okay, will give me x, and that y will be my answer. Okay. Let us do one example. 4 1 by. You can also write it as 4. So a number which you can multiply by itself 2 times will be 4. 2 times 2 into 2. So answer is. Now suppose they asked us to find 4 raised to power 3 by 2. We can write it as 4 raised to power 3 by 1 into 1 by 2. This can be written as 4 raised to power 3 plus 4 raised to power 1 by 2. Sorry. 4 raised to power 3 into 4 raised to power 1 by 2. Because we have a rule x and n equal to x and n. Or it can also be x and so it can be 4 raised to power 3 1 by 2, or it can also be 4 1 by 2 raised to power 3. So 4 raised to power 3 is 4 into 4 into 4 1 by 2. So it is 64. 4 4 is 16, 4 is 64 1 by 2. So it is asking us to find a number that if multiplied by itself twice will be 64, and we know that number will be 8 into 8 is 64. So answer is. We can do it this way also. So this gives us 4. A number multiplied by itself twice will be 4. So that is 2 into 2 power 1 by 2. The answer is 2 raised to power 3. The answer is 2 into 2 into 2. So both ways we can do it. So this gives us one very interesting rule also. That rule is it can be written as 4 raised to power 4 raised to power 1 by 2 raised to power 3, or it can also be written as 4 raised to power 3 raised to power 1 by 2. This can be written as 4 2 raised to power 3, or this can be written as 4 3 squared. This gives us, if it is x raised to power m by n, we can write it as x nth root m, or nth root x m. Note down, it is very important too. Okay, let me write it neatly here. X m by n is equal to n root x raised to power m, or n x. This gives us very important rule. N raised to power x raised to power m is equal to n raised to power x. So if I have an expression that is saying that 2 4 3, I can write it as 2 4 using this. Yes. Friends, if you like this video, then please like, subscribe, share, and comment. And also comment if you want me to do some other videos also. Okay, thank you. Hope you are fine. All the best. Goodbye.